Hello, hello. I'm Chris with the Legacy team, and welcome to another CNC project video. Today we're going to be producing another part for the pedestal bed project, specifically the actual pedestal legs with the castle joints. So far, all of the parts that we've done for the bed have used mostly one workstation, the horizontal workstation, and it's required a one-step process to produce those components. In the last video, we did the side rails, and they used two workstations, the horizontal table and the X-axis clamping fixture, to work on two different faces for the parts. However, this one will require three different cutting processes, and we'll show how that's done using all the capabilities of the Maverick CNC E-Series. The final component that we need to produce for this pedestal bed are the pedestal legs. Now, these will require three different cutting processes to finalize this. Two of them will actually be to the actual part, and then the third cutting process will be to an actual fixture to hold this in the turning center. But this has a castle joint feature that the side rails interlock and overlap within. And then the outer two edges are slightly curved, while the inner two edges are 90 degrees straights. So let's go see how this is done first on the Y-axis vertical workstation. Now, this Y-axis vertical clamping system is a modular option that can be added to the Maverick E-Series at any time. By using both the side clamps and these inserter clamps, we're able to hold the part down in two different directions in the exact same location for all four of these pedestal components. Throughout this entire cutting demonstration, we opened up the dust manifold so that you can see the cutting action take place. To produce this deep castle joint for these legs, we had to use a very long cutter. This is a 3/4 inch down spiral cutter that has a 4-inch cutting length. To ensure that we didn't have any tear out during the finish cut of the castle joint, we first machined the edges, similar to drilling the edges on the horizontal table before cutting the ends. This material was particularly hard, and so we could only take about 3/8 cut depths per pass, and in each cut depth it does a roughing pass and also a finish pass to ensure that the tolerances of this castle joint are very precise. As a matter of fact, we actually adjusted the tolerances to be 0.6 of an inch tighter after our first prototype cut. This roughing cut and finish cut for each pass depth will ensure that the width of the castle joint is consistent throughout the entire depth. Now, before we can proceed to the next cutting process, we need to create an actual fixture that will plug into the end of this castle joint so that we can center this component within the turning center. This castle joint plug is made out of MDF, and we use 3 different cutters to cut it out. An 1/8 inch drill bit to align where the center of the tailstock needs to go. A 1/4 inch spiral cutter to cut out the pockets for the castle joint, and a 3/8 spiral cutter to finish cutting out the shape. We glued up 2 3/4 inch pieces of MDF to double up the thickness of the plug so that we can have enough clearance for the pedestal leg when the cutter actually cuts to the very end of the part. We adjusted the tolerances by the same 0.6 of an inch so that the test fit of this castle joint plug will fit perfectly into the pedestal leg. Now we can proceed to the third machining process. This turning center is also a module option that can be added to the Maverick E-Series at any time. In order to position this castle joint, which is now off-center, this plug will make it so that we can align the tailstock to the middle of the blank. After squaring up the blank to the machine, we can start the program, and this will work on all 4 sides of this pedestal leg. This step will also use 3 cutters to create the finished component. First, the 1¼ inch surfacing cutter to surface plane 2 of the 4 sides. Next, the part will index to the 3rd and 4th side for the second cutter so that we can rough out the material for the curve shape with a 1/2 inch spiral cutter. To wrap things up, we're using a 1 inch diameter extended core box cutter to raster carve both of these curved sides. This component is a great example of using multiple workstations to get access to all different surfaces of our component, allowing us to create any type of design or application for CNC projects. This part was programmed using 2 different software packages. First, Legacy's Conversational CAM Pro software, and second, Vectric's Aspire CAD/CAM software. And there we have it. To finalize the shape, we simply cut off the backside on a miter saw, and we repeated that 3 more times to have a total of 4 pedestal legs. Now, if you're interested in learning more about what a Legacy CNC can do for you, I recommend you visit our website at legacywoodworking.com. Now, if you have any questions and would like to talk to a CNC expert, you can always call 801-491-0010. You can also leave any of your questions or comments down below. Now, if you'd like to see more cutting demonstrations like this, just click right over there. Don't hesitate to like, subscribe, and check that notification box so that you can be notified when new videos come out. And as always, thank you for watching. And remember, Legacy solves more woodworking problems than any other CNC manufacturer in the industry.